Assalamu alaikum and good morning. My name is Hamza Wasim and I am from Group 1 of Lab 2. Today I will be doing the introduction for our project Simple Pendulum. It starts like that. So simple pendulum is a fundamental engineering model used to study harmonic motion and gravitational acceleration. It consists of a concentrated mass known as plumb bob, suspended from a fixed pivot by a string of negligible mass in an ideal system. When the bob is displaced from its equilibrium position, gravity acts as a restoring force, causing it to oscillate back and forth. This experiment explores the core mechanics of oscillatory systems by evaluating how physical parameters, specifically the pendulum length, bob mass, and initial angle of displacement, affect the overall period of oscillation.
Hello and good morning. I will be conducting the data experiment for part A. As you can see, this is the data experiment. In order to get this data, firstly we have to follow the procedure. Firstly, know your apparatus. We are using, in order to conduct this experiment, we are using ruler, long ruler, plumb bob A, B, and C, and then a stopwatch. Moreover, we also use the thread and rod and nut and the panel board of the simple pendulum. And secondly, we have to record the weight of each plumb bob A, B, and C by using a digital scale. After we done with our measurement, the measurement that are shown in the digital scale will be jot down into the experimental data sheet. Moving on, the simple pendulum then is then composed of plumb bob A suspended by a cone which is attached to the threaded rod, and then the pendulum length. Oh, sorry. Before you tighten the rod of the plumb bob, you have to first measure the length of the rod by using a ruler. Measure it from the top to the bottom, approximately around 140 millimeter, and then clamp after measure it, and then clamp between two nuts at the threaded rod. Moving on. Moving on. We are going to displace the pendulum about 10 degrees from its equilibrium position and let it swing back and forth. And then our experiment is to measure the total time taken to make 20 complete oscillation swing, which means this process then will be repeated repeated total time measurement for 3 times and record the time in the table 6.2. And then this step then will be repeat again, but this time we are using angle of 20 degree and 30 degree. And lastly, we are going to do the same thing for plumb bob B and C. Okay.
Terus kata tak? Okay, ikat.
Oh, ni ikat dia?
Ikat.
Oh, ikat. Okay, kan tadi ambil gambar kan? Okay.
Displace the pendulum about 10 degrees from its equilibrium position and let it swing back and forth. Step 6. Make sure the total time that it takes to make 20 complete oscillation. And then for the next step is repeat the total time measurement for 3 times and record that time in table 6.2. After that, repeat step 5 until step 6 using the angle of 20 degree and 30 degree. After that, repeat step 3 until step 7 by using plumb bob B.
Assalamualaikum warahmatullahi wabarakatuh. My name is Isma Hafizuddin bin Ismail. My metric number is AD240046. So let's go to the next part of simple pendulum lab, which is part B. So the first procedure for part B is use plumb bob A, which is the smallest plumb, and set the pendulum length at 100 millimeter or 10 centimeter. And then we go to the next procedure. Displace the pendulum about 20 degree from its equilibrium position and let it swing back and forth. And then we need to measure the total time that it takes to make 20 complete oscillation, which is 20 times the pendulum swing back and forth. And then we need to repeat the total time measurement for 3 times to get the average time and record that time in table result 6.3. To repeat the total time measurement for 3 times to get the average time for each length of pendulum. Alright, from the experiment part B, we need to jot down the result on table 6.3. Firstly is length of pendulum in meter, and then third of L, and then we need to write the total time measurement for 3 times, and also we need to calculate the average result times, and then we need to find the periodic time for one swing, which is T average divided by 20. And lastly, we need to find the acceleration due gravity, which is G, by using formula T equal to 2 pi set L over G, or we can simplify the formula by G equal to 4 pi square L over T square.
Now I will do the conclusion from experiment. The experiment successfully demonstrates the factors that affect the oscillation time of a simple pendulum. First point is length affects the time. A longer pendulum length increases the time taken to complete the oscillations, showing a direct relationship between length and the period. The second point is mass has no effect. Changing the weight or type of the plumb bob does not alter the oscillation time. The third point is angle has no effect. Varying the initial displacement angle from 10 degree to 30 degree does not affect the time, as long as the angle remains relatively small. In short or overall, the period of a simple pendulum depends entirely on its length and gravity, while being completely independent of the mass and the angle of release. That will be all from me today. Thank you.